Hello guys, my name is Bob. Welcome to the Excel Math channel. And today, alright, I'm going to continue explaining using definition of chi-square distribution. Previously, I've published a video explaining the definition of chi-square distribution. So that is part one. If you guys want to understand the definition of chi-square distribution, you can actually refer to the link below, okay, which will direct you to the video that explains about the chi-square distribution. All right, so this is part two. The next definition that I'm going to break down is actually this. If u1 un is chi-square 1 or chi-square with a degree of freedom 1, then the distribution of v equals to u1 plus plus un is called the chi-square distribution with n degree of freedom. All right, we write v and some curly sign chi-square n. Okay, so what does this basically means? Right, so first thing first, it says that if u1 un un itself, they are chi-square 1, so which means to say that my u1 is chi-square distributed with degree of freedom 1. All right, the sum of the chi-square distribution the sum of the chi-square random variable with degree of freedom 1, if you were to plot the distribution of it, it's called a chi-square distribution with n degree of freedom. So let's say, for example, all right, we have v is equals to u1 plus u2. So the distribution of v in this case would be chi-square 2. All right, if let's say I have w is equivalent to u1 plus u2 plus u3, where each of the u itself are chi-square distributed random variable with a degree of freedom 1, w, which is a sum of 3 chi-square random variable with degree of freedom 1, and you plot the distribution of w. All right, so this w itself is, it has a distribution of chi-square with a degree of freedom of 3. All right, so we can say the same thing for, let's say, for example, z is equals to u1 plus u2 plus plus un. Right, so in this case, each of the u itself is a chi-square, all right, random variable with a degree of freedom of 1. So z itself, if we were to plot the distribution of z will have this distribution, which is a chi-square distribution of degree of freedom of n. basically because there are n random variables. All right. So some people actually talks about n minus 1. All right. Why is this n? Sometimes when you have n chi-square random variables, and the distribution is actually n minus 1. All right. Where does this minus 1 come from? All right. So if you were to realize that degree of freedom is not only just depends on the number of variables, all right, it actually depends on, okay, if let's say there is, I mean, the number of parameters that you're estimating, all right. So if I were to do some cleaning up of this thing, and I will show you what do I mean by it, all right. Let me just go on to here. All right. So let's say, for example, okay, my chi-square, okay, okay, U1, okay, is chi-square distributed whereby your U1 itself is actually, let's say, x1 square, but x is not, okay, x is actually kind of like y minus mu over sigma square. Okay, so that means what happens is that originally you have, your yi's, okay, they are actually normally distributed instead of standard normal with mean, mu, and sigma square, and hence you have to convert, this y to a standard normal. We call this as x, which is the standard normal is actually y minus mu over sigma square. So this whole thing itself is a standard normal, and you square it, all right? And then the thing is that you want to estimate mu because it's unknown, all right? So if you are given, let's say for example, in this case, w is equals to the sum of u1s plus dot 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 plus un. We know that u1, okay, they are all chi-square, but the only difference is that this yi itself, okay, this yi itself, instead of being a standard normal, it is actually normally distributed with mu and sigma square. So for this case itself, because you have to estimate your mu by using the sample mean, so when you do, okay, the distribution of w, yep, it's a sum of u square, u1 square. Is it sum of u? No, sum of u1s, sum of ui's, okay? And this sum of ui's is equal to the sum of x I square just by substitution, and this is actually equals to the sum of y I minus mu over sigma, and this is I equals from 1 to n square. So because this yi, okay, itself is not standard normal distributed, but it's normally distributed with mu and sigma square. So, and the mu is unknown, so instead of using mu, we use x bar to kind of like estimate my mu. So when we do the estimation itself, we do not know what is mu. When we do one estimation, we have to subtract 1 degree of freedom away from, okay, the degree of freedom, basically. So w is actually chi-square distributed, but it's just the degree of freedom of n minus 1 because we have to estimate my mu since my mu is unknown. All right, that means my yi itself, the mu is unknown, so we have to subtract 1. Okay, so that's it for right now. Thank you guys for watching. I hope this actually explains clearly about, you know, the concepts and the definition. Thank you so much, and I will see you in the next video.